Welcome to this deep dive. We're going to explore a pretty fascinating breakthrough in AI.
Oh, yeah.
How to make those incredible multimodal large language models really see the world.
It's all about elevating their visual perception, I guess,
hmm
taking it to a whole new level.
Our source material today is a research paper that really caught my eye.
Okay.
OLA VLM, Elevating Visual Perception in Multimodal LLMs with Auxiliary Embedding Distillation.
Wow.
It's quite a mouthful,
Yeah,
but trust me, it's worth unpacking.
it really is. The researchers have developed a new method. It's called OLA VLM, and it could revolutionize how AI interacts with visual information.
So imagine AI that can not only process text, but actually understand images the way we do,
Yeah.
leading to smarter visual search, more engaging chatbots, and who knows what else.
The possibilities are truly mind-boggling. I mean, it's crazy to think about.
Now, the paper starts by highlighting a key problem.
Mm.
Current MLLMs, even though they can handle images, rely heavily on text descriptions.
Right.
So it's like they're trying to understand a painting just by reading about it.
Yeah.
Not exactly the most immersive experience.
No, it's like trying to appreciate a symphony just by reading the sheet music.
Yeah.
You're missing the richness and complexity of the actual performance.
Exactly. And that's where the researchers dug deeper to figure out what's going on inside the brain of an MLLM. They used a technique called probing.
Like, imagine being able to peek into the different layers of an MLLM and see how it's processing visual information.
Like a behind-the-scenes tour of the AI's visual system.
Precisely. They took an existing MLLM, it's called LLV 1.5, and they used these probes to analyze its visual capabilities.
So what did this digital deep dive reveal?
Well, they found that the middle layers of the MLLM were the most active
Okay.
when it came to understanding visual information, kind of like the visual cortex in the human brain.
Makes sense. But here's where it gets really interesting. They also discovered that simply training the MLLM on more and more data, even visual data, didn't completely solve the problem of limited visual understanding.
Right. It's like, if you just kept reading more and more descriptions of paintings, you might learn to recognize certain key words or themes,
Yeah.
but you wouldn't truly grasp the visual essence.
So more data is helpful, but it's not the magic bullet. There's something deeper at play here.
Right. And that's the brilliance of OLA VLM. It tackles this challenge head on
Hmm.
by essentially giving the MLLM a specialized visual education.
Okay, I'm hooked. Let's unpack this OLA VLM. How does it work?
Well, the core idea is to tap into the knowledge of specialized visual models,
Okay.
those that excel at specific tasks. Like depth perception or image generation. It's like having expert teachers for each visual skill.
So instead of just throwing raw data at the MLLM, we're giving it structured lessons from the pros.
Exactly. OLA VLM borrows the expertise of these specialized models and uses it to refine the way the MLM sees the world.
This is where I start to get a little lost in the technical details.
Oh, okay.
How does this knowledge transfer actually happen?
Well, it's a bit like showing the MLLM examples from these expert visual models and then nudging it to interpret images in a similar way.
So it's not just about copying the outputs, it's about guiding the MLLM to develop a deeper understanding.
Precisely. And they achieve this through a clever combination of techniques.
Okay.
One is using special tokens that are added to the input and carry information about specific visual tasks.
So it's like adding labels to the images saying, hey, focus on the depth here, or pay attention to the different objects in this scene.
That's a great way to put it. These special tokens act as visual cues, guiding the MLLM to prioritize certain features and process images more efficiently.
It's like giving the AI a cheat sheet for visual understanding, but one that helps it unlock a much richer level of perception.
It's fascinating to see how researchers are blending the power of language models with the specialized skills of visual experts.
So all of this sounds incredibly promising, but does OLA VLM actually deliver the goods? Does it really improve how MLLMs see?
That's the million-dollar question. And the research suggests a resounding yes. The results are truly impressive.
Okay, let's dive into those results. What kind of improvements are we talking about?
Well, on tasks that involve understanding 3D space,
Okay.
things like depth perception and distance estimation,
Yeah.
OLA VLM really shines. It consistently outperforms existing MLLMs.
So it's not just recognizing objects in an image, it's understanding where they are in relation to each other. That's a huge leap forward.
Absolutely. And get this, OLA VLM achieves this level of performance while actually being more efficient than some models that try to improve visual understanding
Okay.
by using multiple visual encoders.
Multiple encoders. You lost me there.
Imagine some models trying to understand an image
Hmm.
by having several different eyes looking at it
Okay.
from different angles, processing it separately. That's the multi-encoder approach.
Okay, so more processing power. But OLA VLM is doing more with less.
It's exactly. It shows that sometimes smarter learning is more effective than just brute forcing the problem with more processing power.
Right.
OLA VLM is making the MLRM a more efficient learner.
Right, so it's not just about seeing better, it's about seeing smarter. And I'm all for smarter AI, but let's shift gears for a second. We've talked a lot about the tech, but what does this actually mean for us regular folks using technology every day?
That's the exciting part.
Yeah.
Imagine a world where search engines actually understand the content of images,
Yeah?
not just the text around them.
Give me an example. How would that change my life?
Let's say you're searching for a photo of a dog wearing a red bandana sitting on a striped beach towel.
Okay.
Right now, you probably get a ton of pictures of dogs, some with bandanas, maybe some on towel.
And a lot of beach pics that have nothing to do with dogs.
Exactly.
Yeah.
But with a visually savvy AI like OLA VLM powering search, you could actually find exactly what you're looking for.
No more scrolling through pages of irrelevant results. That's search revolutionized. What else can I look forward to?
Think about online shopping. Instead of filtering by vague descriptions or colors,
Right.
you could search for clothes based on really specific visual details. Imagine searching for a dress with a floral print, but only with roses, not daisies.
Okay, now that's game-changing. My online shopping struggles are legendary.
Or imagine searching for furniture that matches a specific style, even if you don't know the name for that style.
Right.
OLA VLM could bridge that gap between our visual ideas and the limits of words.
It's like having a personal AI stylist or interior decorator. I can get behind that. But can't just be about shopping, right?
Yeah.
What about more practical applications?
Think about virtual assistants that can give you directions based on what they see through your phone's camera.
Okay.
You just point and say, how do I get to that little bookstore with the green awning?
No more fiddling with maps. I'm already sold. But what really gets me excited is the potential for accessibility.
Absolutely.
Mm.
Imagine how much richer and more detailed the world could become for people who are visually impaired with AI describing what's around them.
And I bet that's just the beginning. This technology could open up so many possibilities for people with all sorts of disabilities.
And let's not forget entertainment. Think of video games, where characters react realistically to their surroundings, or education tools that can explain complex scientific concepts with interactive 3D visualizations.
It's like seeing becomes a whole new way to learn and experience the world. I'm getting chills just thinking about it.
And remember, OLA VLM is just the starting point. As this technology develops, we can expect even more amazing applications that we haven't even dreamed of yet.
I'm starting to feel like we're standing on the edge of a major technological shift. But before we get too carried away, let's take a closer look at how OLA VLM actually pulls off this visual magic. Earlier, you mentioned something about predictive embedding optimization. Can you break that down for me?
Think of it this way. Inside an MLLM, images are represented in complex mathematical ways.
Okay.
These representations are like the model's understanding of what it's seeing.
So it's like the MLLM's internal language for understanding visuals.
Right. And the quality of these representations directly affects how well the model performs visual tasks.
Okay.
OLA VLM is all about improving those representations, making them more accurate and detailed.
So it's not just showing the model more images, it's teaching it to interpret those images more effectively.
Exactly. And that's where the knowledge from those specialized visual models we talked about comes in.
The ones that are experts in depth, perception, and image generation.
Right. They've already learned to generate very precise representations for those tasks.
Yeah.
OLA VLM uses a method called embedding distillation to transfer that knowledge to the MLLM.
So it's like those expert models are giving the MLLM a crash course in visual understanding.
It's like a mentorship program for AI.
Yeah.
And to make things even more efficient, OLA VLM uses those special tokens we mentioned.
Right, those tags that tell the MLLM what to focus on.
Exactly. They help the MLLM prioritize certain visual features so it's not wasting time processing irrelevant details.
It's like giving the AI a roadmap for visual understanding, showing it the most important landmarks. This whole approach is so clever. It's like combining the strengths of large language models with the expertise of visual specialists.
And the results speak for themselves. This is a major step forward in how AI sees the world.
I'm blown away by the possibilities, but I also have to wonder, are there any potential downsides or challenges with this technology? What are we not seeing?
That's a great question, and it's important to approach any new technology with a healthy dose of skepticism. One challenge is that OLA VLM relies on those expert visual models for specific tasks.
So if there isn't a good expert model for a particular task, OLA VLM might not be as effective.
That's a possibility. It highlights the importance of continuing research and developing those specialized models, especially for more complex visual challenges.
So the progress of OLA VLM is tied to progress in other areas of AI.
It's all connected. Another thing to consider is the computational cost. Even though OLA VLM is more efficient than some other approaches, it still requires significant processing power, especially during the training phase.
So access to this technology might be limited for a while until it becomes more computationally affordable.
Right. Making this technology more accessible and less resource intensive will be key to its widespread adoption.
This has been an incredible journey so far. We've gone from the limitations of current AI to the incredible potential of OLA VLM, but I can't help but feel like there's still so much more to uncover.
There always is. This is a field that's constantly evolving.
Let's take a quick pause and then we'll wrap up our deep dive with some final thoughts on the big picture implications of AI vision. Stick with us. Welcome back to the final leg of our deep dive into AI vision. We've talked about the limitations of current MLLMs, the genius of OLA VLM, and its mind-blowing potential.
Yeah.
But now I kind of want to shift gears a bit and get philosophical.
Oh, okay.
So we keep saying that OLA VLM helps AI see better, but what does that really mean? Yeah. Is AI actually experiencing the world the way humans do?
That's a question that has sparked, countless debates. I think it's important to remember that AI, even with advancements like OLA VLM, processes information fundamentally differently than humans do.
We're not just talking about recognizing objects, right?
Right.
There's a whole layer of interpretation and meaning that goes into human vision.
Exactly. We bring a lifetime of experiences, emotions, and, cultural context to the way we see the world. Think about looking at a family photo.
Yeah.
You don't just see individuals, you see relationships, history, shared memories.
You see a story unfolding in that single image.
Right. And AI, even with OLA VLM, is still catching up in that regard.
Okay.
It's more about analyzing visual data, identifying patterns, and making connections.
So it's like AI is seeing the world through a more analytical lens,
Yeah.
even as it becomes more sophisticated.
For now, yes, but the
Okay.
gap is definitely closing. With techniques like OLA VLM, AI is moving beyond just recognizing objects. It's starting to understand spatial relationships, depth, and even some basic semantics connected to images.
So while AI might not be experiencing the world exactly like humans, it's developing its own kind of visual intelligence.
Precisely. And that's what makes this field so exciting. We're witnessing the emergence of a new form of intelligence,
Wow.
one that could reshape how we interact with technology and with the world around us.
Okay. So let's put on our futurist hats for a moment. What are your predictions for the future of AI vision? What might the next 5 to 10 years hold?
Well, predictions are always tricky, but I think we'll see a convergence of several exciting trends.
I'm all ears.
First, I think AI models will become increasingly multimodal.
Okay.
We'll see more models like OLA VLM that seamlessly blend visual, textual, and even auditory information.
So AI won't just see, it will also read, listen, and process information from multiple sources at once.
Exactly. And that will lead to AI systems that are much more adaptable, intuitive, and capable of understanding complex situations.
That's pretty mind-blowing. What else do you envision?
I think we'll also see a shift towards more personalized and interactive AI experiences. Imagine AI assistants that can understand your visual preferences, anticipate your needs, and even interact with the physical world on your behalf.
So instead of just responding to our commands, AI will become more like a collaborative partner, almost an extension of ourselves.
Right. And last but not least, I believe AI will play a vital role in tackling some of the world's biggest challenges,
Okay.
from climate change and healthcare to education and global accessibility.
It's inspiring to think that AI could be a force for good in the world.
It has that potential,
Yeah.
but it's up to us to ensure that it's developed and deployed responsibly.
That's a crucial point. This technology is incredibly powerful, and we need to be mindful of its impact on society.
Yeah.
We need to make sure that AI benefits everyone and that it's used to create a more equitable and sustainable future.
Absolutely.
Well, I don't know about you, but after this deep dive, I'm feeling a mix of excitement and awe. We've glimpsed the incredible potential of AI vision, And it's clear that we're just at the beginning of this journey.
It's a truly fascinating time to be alive and to witness these technological leaps firsthand.
And who knows what incredible discoveries await us just around the corner.
Right.
That's the beauty of exploration. There's always something new to learn and wonder about.
Curiosity is the fuel that drives innovation.
And on that note, we'll wrap up this deep dive. Thank you for joining us on this exploration into the world of AI vision. We hope you learned something new and left feeling inspired by the possibilities that lie ahead.
It was a pleasure sharing this journey with you.
Until next time, keep exploring, keep questioning, and keep diving deep into the fascinating world of knowledge that surrounds us.